Okay, so further in space physics, before starting the concept of redshift and blueshift, there is a concept of Milky Way. So if we talk about the Milky Way, so the concept of Milky Way is just like this, that in our universe, we are having galaxies and galaxies are made up of billions of stars. So if we consider the example of a galaxy or galaxies, so galaxies are made up of billion of stars. So you just imagine that if we consider a single galaxy, so that single galaxy is made up of billions of stars. So multiple galaxies are made up of how many billions of stars, and how much the universe is expanded, and how much is it is going to be expanded. So that will just give you a rough idea about the limitation of the universe, that how much or how much Earth or universe is going to be expand in day by day or in our future. So galaxies are made up of billions of stars, and we know that there is not a single galaxy in our universe. There are multiple galaxies. So that's why if we imagine the galaxies, so how long distance we have to cover to find out the universe or the length of the universe. So that's why there is no accurate theory about the time travel and that parallel universe, that scientists try to find out the time travel and the parallel universe concept, but universe is expanding day by day, time by time. So that's why it is not possible to find out the exact position or exact point, because initially when they are observing, after some day or after some time, that thing is going to be expand from that place. So that is something different. And further, if we talk about the universe, so universe is made up of many galaxies. So there are many and also different type of galaxies in the universe, but we need to know about that our Milky Way, and in our solar system where we find the Milky Way, and where actually it is going to be head over there. So in our solar system, we consider sun as a star. So sun is a star in our solar system, and we also consider the sun as a star in billions of stars in a galaxy. And if we talk about the concept of the universe, galaxies, and billions of stars, so we start discussing about the galaxy, that galaxy is made up of billions of stars, and universe is made up of different galaxies. So sun is also a type of star among all these billions of stars in the galaxy. So that galaxy in which sun exists, so we are talking about the galaxy in which sun exists, so that galaxy is known as the Milky Way, right? So the concept of Milky Way is very simple, that if we consider the sun, because sun is also a type of a star, and when we are talking about the star of a specific galaxy, so that galaxy which contain sun as a star, so that galaxy is known as the Milky Way, right?
Yes, sir.
And there are multiple stars or some other stars also present over there, but the gravitational force of sun and the mass of the sun is greater among all those other stars. So that's why we consider the Milky Way as the galaxy of the sun, or the sun as a star in that specific galaxy. So that is known as the Milky Way. And further, if we talk about the distance, because all other stars are at some distance. because sun is also at some distance if we consider our point or our earth from the sun. So the distance of the earth from the sun is something different. So all planets have their different distance or different space from some other planets. If we consider some other comets and asteroids, so there are multiple positions of those asteroids and comets as compared to sun and different planet. So if we want to find out the distance, so how we can find out the distance in the space? Any idea? How we measure
Light years?
light years? So light years is the unit that we use in space to find out the distance between different planets, right? Or different stars. So if we talk about the astronomical distance, so astronomical distance such as the distance between stars and galaxies, so that distance is known as astronomical distance. So the distance between a star and galaxies are so large, so that's why we have to find out something to calculate the distance. So that's why we use a special unit, and that special unit is known as the light year to find out the distance between those asteroids, those stars, those galaxies. So light year is the unit to find out the distance between stars and galaxies in the universe. And we know that one light year is equal to the distance traveled by the light through vacuum or space in 1 year. So light year is a simple concept. It is a distance traveled by the light through space in 1 year. So that is the concept of light year. And that is also very simple. We already know about that light year concept. And the speed of light is also very simple. And if we just talk about the Milky Way, so for the Milky Way, the distance of Milky Way is, or the diameter of Milky Way is 100,000 light years. So it means if we pass light from one point of the Milky Way to the other point, that is the diameter of the Milky Way. So light will take 100,000 years to complete that distance. So you just imagine that how long diameter of a single Milky Way is. And if we consider some other Milky Way, some other galaxies, because Milky Way is only a diameter of a single galaxy, and if we consider all other galaxy, all other planets, or other comets, asteroids in the universe, so how long light will take to cover the whole distance in the universe, that is not calculatable, or that is not accurate or the fixed value to find out the distance or the age of that universe starting from one point to another, right?
All right, sir.
Okay, further if we talk about the concept of the redshift and blueshift, that is important. because this concept is very much related to the electromagnetic spectrum. So that's why they mostly asked about this concept. So if we talk about the redshift and blueshift, so that concept of redshift and blueshift is basically related to the distance or the direction in which galaxies are moving or different planets are moving from each other. So that is specifically related to the direction. So before writing the definition for blue shift and the red shift, first we need to consider a very common example, then we will have an idea of what is red shift and blue shift. Let's suppose if we consider, just take the example of a train or an ambulance. So let's suppose if we take the example of an ambulance. Okay, so normally we consider ambulance over here and the siren of ambulance is continuously alarming over there. So these are the sound waves which are going to be produced by this ambulance. Okay, so these are the sound waves which are going to be produced by this source. And ambulance is not moving in any specific direction. So ambulance is still, that's why it is emitting sound in all direction with equal distance, right? Now, if let's suppose if this ambulance start moving towards right or towards left, let's suppose if it starts moving towards right hand side, so what will be the pattern of the wave then?
They will be towards left hand side.
Yes, if we consider the pattern of the wave when it starts moving towards right or left, oh, so let's suppose this source will start moving towards right hand side. So the new pattern of the waves will be like this. So the distance on the left hand side is going to be increased as compared to the distance on the right hand side because the source is moving on right hand side. So that's why the waves are going to be shrink on right hand side and it is going to be extend on left hand side like this. Any confusion?
No, sir.
Okay. So now if we talk about some uh, fundamental terms related to the waves. So if you remember that if you want to find out the wavelength, so initially if we talk about the rest state of the ambulance, so we can easily find out the wavelength from this distance, right? This will be the wavelength of the waves or the sound waves that are going to be generated by the ambulance or by the source. Let's suppose if you are standing on the platform and its train is coming towards you or moving away from you, so there will be a different observation of the siren of the train, just like the ambulance. So when something is coming towards us, so we hear sound with greater intensity, and when that source is moving away from us, so we observe sound of low intensity. So same goes over here that on right hand side, the wavelength is going to be decreased over here. The wavelength is very much short. So wavelength decrease and when wavelength will decrease, let's suppose if we consider the source. So when source is moving away from us or towards us, let's suppose if observer is placed, so this is our observer. It means that source is moving towards the observer, right?
Yes.
Initially, source is moving towards observer. So when it is moving towards the observer, so wavelength will decrease and which quantity will increase?
Frequency.
Frequency will increase, yes. So frequency will increase and the wavelength will decrease. And if we consider that, let's suppose if source is moving away from the observer, let's suppose if observer is at this point, so now source is moving away from observer, right? So now source is moving away from observer and in this case source is moving towards the observer. So now we can clearly see from the diagram that the wavelength on the back side is going to be increased, right?
Yes.
So wavelength will increase and further if we talk about the frequency, so frequency will decrease, right? So this is a very common concept of our daily life. We didn't talk about the redshift and blueshift till now. We only talk about the change of frequency and wavelength with the reference of a normal source sound. Okay,
Right,
now
sir.
now if we want to compare it with redshift and blueshift, how we name that red and blue. So now start talking about that electromagnetic spectrum or that visible light region. So if we take the example of that visible light region, in the chapter of electromagnetic spectrum, we draw that timeline. And in that timeline, we discuss that if we move towards the right hand side, so on right hand side, we consider wavelength is increasing, right? And on left hand side, we are working with increasing frequency. So there are different type of concept we studied in electromagnetic spectrum that those waves which are on the right hand side have their wavelength increasing and those waves which are on left hand side are having uh, increasing frequency, right? So if we consider the visible light region, let's suppose this whole black box is made up of a visible light region. So red color is on the right hand side. If we consider that seven colors, because we know that white light is made up of seven different colors, so red will be on right hand side and which color will be on the left hand side?
Purple.
Yes, so that will be on left hand side. And further if we talk about that seven different colors, so starting from the violet color, so violet, indigo, blue, so then we will get a blue color over here. So this is a very common concept of electromagnetic spectrum. Now try to compare the concept or try to interlink the concept of that sound source or that stationary and moving observer concept with this electromagnetic concept. And that concept of sound is specifically known as the Doppler effect. This whole concept is known as the Doppler's effect. They don't ask about you a specific Doppler effect because Doppler effect is the part of the A level, but it is important to understand that how redshift and blueshift form So that's why this concept is very much important, because that will make easy for you to understand that how Redshift and Blueshift are going to be formed, right?
Right, sir.
So now if we talk about a Redshift, so finally we conclude all these values. So now if we talk about the definition of Redshift, so Redshift is an increase in the observed wavelength. We are writing observed wavelength because we are going to compare the wavelength and frequency. So frequency and wavelength are relative. They are not fixed because it depends upon the position of observer and the motion of the source of electromagnetic radiation emitted from stars and galaxies. So basically, redshift is for the increasing wavelength. You also observe from the concept of electromagnetic spectrum that we consider this red color on the right hand side, and right hand side means the wavelength of red color is increasing. So that's why we use the concept of redshift when the wavelength is going to be increased. And when wavelength will increase, when planet is moving away from some other planet, right? Or when we are talking about a star. So let's suppose if we are having the examples of a star, and this star is at the center. So let's suppose some other star is moving away from it like this. So wavelength is going to be increased over here as compared to the this yellow star and the red star. Just like the concept of this, that source is moving away from the observer. So when we are moving away, so that is known to be as redshift. And when is a star is moving towards the observer, so that is known as the blue shift, right?
Yes.
So further we can write it as light from a star that is moving towards an observer will be known as blue shift or red shift.
Blue.
Yes, blue shifted. And when it is moving away,
Red.
yes, then it will be red shifted. So this is the concept of red shift and blue shift, and that is very much important. That's why I explain the whole concept of Doppler's effect first so that you will get the idea of the wavelength and frequency, how wavelength and frequency are going to be changed, and that will help you to answer the question that why we observe the blue shift and why we observe the red shift and what is the concept of this red and blue shift. So this is a simple concept of different wavelength and frequency as compared to the star and the observer, that if stars are moving away from the observer, so that is going to be red shifted, and if stars are moving towards the observer, so that is blue shifted. So basically all this depends upon the concept of electromagnetic spectrum and the colors of that visible light. So that's why we name them red and blue, because that is related to electromagnetic spectrum. Any confusion?